So the next the next examples I'd like to go over in the video are these two, and they tend to be more challenging examples I find for students overall. So I'd like to look at them and go through them in a little bit more detail. We did do them in class as well, but again, it's good to see these done more than once and to just see them done out in detail each time. So in the first example, it says the mean charge for electricity for a sample of households was $110 a month with a standard deviation of, and this should be $16.50 per month. Between what two values do 95% of the data lie? And we're going to assume the data has a bell-shaped distribution. So this is a question that we do see come up often enough. And notice a few things. We're asking for a percentage here, right? Or we're referring to percentages. So what two values do 95% of the data lie? And we're also assuming a bell-shaped or symmetric distribution. When you see those things combined, we want to think about the empirical rule there. And this is how we can set up the empirical rule. So I'm going to draw the picture for you guys. And I'm going to start by drawing an axis on the bottom. We have sample here, data, and the mean is $110. And then the standard deviation is $16.50. So the mean is in the center. And then to make a chart for the empirical rule, and again, I do like to do a visual for this one, I think it really helps, is we're going to go on the right up by one standard deviation first. So 110 plus 1650. And when I do that, I get 126.50. And then we're going to go up again by two standard deviations this time. So 110 plus 2 times 1650. Don't forget, make sure you do order of operations here first. You'll get 33 there. And then when you add to the 110, we have 100 and, 43. And then typically for empirical rule, we go out to 3 standard deviations, but it's the same process. We're going to add 3 times the 1650 this time, and then add it to the 110, and we're going to get $159.50. And we're going to do the same thing on the left side, but with subtraction. So for the first tick mark, we're going to take the mean and subtract 1 standard deviation. So when we do that, we have $93.50. Then we're going to take the mean and subtract 2 standard deviations times 2. Again, don't forget, do the multiplication first and then go ahead and subtract, and you'll get $77 even. And then we can go out a third standard deviation, again, just to create the picture here. And we take that 110 minus 3 times the 1650. And in that case, you would get $60.50. Now, this works for bell-shaped data. So your data, kind of basically looks like this, and it should be symmetric, but it's, kind of a bell shape here. And what the empirical rule says is a few things. So it basically says that 68% of data is within 1 standard deviation. So what that means is between the mean minus 1 standard deviation and the mean plus 1 standard deviation. So 68% is sort of right in the middle here, this group, right? Between 1 standard deviation either way. It says that 95% is within 2 standard deviations. Again, now what that means is you're going from the bar x bar minus 2x up to x bar plus 2s. And that's the one that we're looking for here, right? We're looking for 95%. So here's the center, and we're going 2 standard deviations. So we're going out 2 in both directions. So we're going from here, x bar minus 2x, up to here, x bar plus 2x. So what the empirical rule says is that this area here is 95% of the data. And then if you wanted to go, we don't need it here, but a little bit further, we have 99.7% within 3 standard deviations. So again, minus 3s up to plus 3s. So if we expanded our graph a little bit more and included all of that, we'd have almost 100%, right? 99.7%. And this is what the empirical rule says. So for this particular question, we want to know between what two values do 95% of the data lie? So for this question, we want 95%, which is 2 standard deviations. So basically from 77 up to 143. So between $77 and $143, 95% of the data lie. All right, so based on this sample, basically of households who are being charged for electricity, most people pay between $77 and $143, right? Not everybody. Some people pay lower, some people pay higher. Even beyond these, right, there could be exceptions going even further. But 95% is a really good chunk here. So most people pay between $77 and $143 for the electricity based on this sample. Now, the empirical rule only works for bell-shaped data. Don't forget, and you can review this as well, Chebyshev's rule works for all shaped data. So we have something very similar. In that case, the value is 75%, and then 88.9% instead for 2 and 3 standard deviations. But again, kind of similar process. It's just that your data does not have to be bell-shaped. Now, the other example I want to go over here is how to work with grouped data a little bit more. So again, we've talked this out in class, but we haven't really done like a full example. So here we have a random sample of households. And in that, we look at the number of TVs in each household. So we're going to find the sample mean and sample standard deviation of the data. And this is grouped data. So again, in grouped data, basically you have a lot of repeats. So the numbers are all very repetitive. For number of TVs, most people probably have between 0 and 5 TVs, right? Obviously, you could have some exceptions, but the data tends to be pretty similar, right? Having, 0, 1, 2, 3, 4, 5 TVs, that's probably where most people are going to be. So your data is very repetitive. You're getting the same answer over and over again. And that is grouped data. The process is very similar if you want to use a frequency table. Instead of using the raw data, we use midpoints though, and it acts as an approximation instead. So again, you can check that out more in our lecture from class or in your text if you want to see an example there. I figured I would do a grouped data example here just to kind of demonstrate it one more time. So a couple things to know is the number of TVs is the actual data. Right? How many TVs do you have at home? Oh, I have 0 TVs. I have 1. I have 2. I have 3, and so on. And then the number of households, this is actually the frequency, right? So 1 household said they had 0 TVs. 8 households said they have 1. 13 households said they have 2. 10 households said they have 3, and so on. So for grouped data, the first thing I want to do is how to find the mean. This is sample data, so I would use the X bar notation here. And what we're going to do is we're going to use multiplication to help us write this quicker. So for instance, 1 household had 0 TVs. So I can write that as 0 times the 1 household. And then 8 households had 1 TV. So I can write that as 1 times 8. Again, instead of writing 1 plus 1 plus 1 plus 1 8 times, like a regular average, we're just saving some writing here. That multiplication can be used for repeated addition. Now, for 2 TVs, there were 13 households. So again, instead of writing 2 plus 2 plus 2 over and over again 13 times, I can write 2 times 13. It's just a shortcut. There were 10 households that said 3 TVs, 5 households that said 4, and then 3 households that said 5. Now you are dividing by the total number of data points, which is also the frequency. So if you add up your frequency row here, and I'll let you try this at home, so the 1, the 8, the 13, the 10, the 5, and the 3, you do see that there are 40 households. Right? So this is your N or your number of data points. So we go ahead and we would divide this by 40. Now you can try that adding at home. I got 99. And when divided by 4, I got 2.475. So if you wanted to, you could round that to about 2.5 TVs. So the average there is 2.5 TVs. And this sort of makes sense based on the data, right? You can see that most of the data is between, is really around 2, but that 1, 2, 3 range, right? So 2.5 seems to make sense here. Now, we can also find the standard deviation. I'm going to use S there, right, for my notation because it's a sample. And I'm going to do it by hand. So for grouped data or for frequency tables, we typically do that by hand. So what we're going to do is we're still going to start. I'm going to write our X column here because I like to have that down. And again, our X values would be 0, 1, 2, 3, 4, and 5. And then think back to how do we do standard deviation by hand? The first thing we do is we take each of those X values and we subtract it with the mean. So I'm going to take the 0 and I'm going to subtract it with my mean. Now I'm going to go ahead and use the full version here. I always think it's better to use more decimal places. You can always round later, but you can't add extra decimal places on at the end. You could also read the directions on your homework, for instance, and see how many decimal places they want. They only want, 1 decimal place in your answer, then we probably don't have to use quite this many. But if they're going to ask for 2 or 3, then you need to use all those decimal places. So I'm going to go ahead and use my calculator and subtract these, and I did it already. So the first value came out to be negative 2.475. The second value came out to be negative 1.475. The third value, negative 0.475. 3 minus 2.475 is positive 0.525. Next is 1.525. And finally, the last one, 2.525. Now, the next thing that we did here, and I'm going to just kind of combine this so I save some writing, is we took that value and then we squared it, right? So now we square it. And when we square each of these values, again, you're just going to use your calculator here. And what I get for the first one is 6.1256. The second one, 2.1756. 0.2256, 0.2756, 2.3256, and finally 6.3756. And again, you can do some rounding here too. Like I said before, I would look at your problem and see how many decimal places your final answer needs to be, and then kind of make a decision after that. If your final answer needs 2 decimal places, I would always go out 1 extra in your work though, so you'll be able to round appropriately. So if you need 2, you're probably still working with at least 3 decimal places in your work, for instance. All right, now what we've done so far is just the basic calculation for standard deviation. So nothing has really changed yet. And here's where the difference is going to be. Because we have grouped data, each of these values, 1, 2, 3, and so on, don't necessarily just appear one time. Now, the value 0 only appears one time, but the value 1 appears 8 times, and the value 2 appears 13 times, and so on. So really, I should be having that value 1 8 times. I should have that value 2 13 times, and so on. So I'd have a really big table, right? I'd end up having 40 rows altogether if I actually wrote out each of those individually. So again, to save that time so that we're not writing out repeated data, we're going to use multiplication. So for group data, what you're going to do is you're going to multiply by the frequency in each case. So in the first one, for 0, it's just times 1. So again, you're not going to change anything there. But in the second case, you're multiplying by 8 of those because really I should have 8 rows of 1s. And when I do that, I get 17.4048. The next one you're multiplying by 13, which is 2.9328. The next one we're multiplying by 10, so 2.756. The next one by 5, which is 11.628. And finally, the last one is by 3, which is 19.1268. So here's the difference when you have grouped data, and it's also very similar when you're using the frequency table because you're going to have frequency counts, you're going to multiply by them. And again, it just saves some work. It's a little bit of a shortcut. After that, we go back to the usual stuff. We're going to add these all up. And when you do that, again, I'll save you guys the work on that end. You can check it at home. I'm getting 56.974 when I add that all up. So I'm almost done here. So standard deviation, we add it all up, and then don't forget we have one more extra step basically. So we're going to take the square root of it. That 56.974 is going to go on top, and then we're going to divide. Now, keep in mind that this was sample data, right? In the problem, it did say that we have a sample of households right here. So when we are using standard deviation, we have to use the sample formula, right? Same thing for variance. Those have different formulas based on samples or populations. In the sample formula, the denominator is n minus 1. So in this case, we had 40 households. So instead of dividing by 40, I'm going to divide by 39. And again, we only do that change if it's a sample. If it was a population, I would just use the regular 40 that I'm used to. But I'm not here. So it's a sample. I'm going to use 39 instead. You're going to take out your calculator and you get about 1.208. So maybe about 1.2 TVs. Again, don't forget the units are the same for standard deviation. So they look a little bit weird, but 1.2 TVs would be the standard deviation here. So I hope that example helped to illustrate a little bit more. Again, these are a little bit trickier. The math is not difficult, but it's just a lot of steps. So we start with a regular calculation by hand for standard deviation. The only difference is we multiply by those frequencies. And again, the reason is it's just easier. It's a shortcut. Instead of having to write out 40 rows, I only write out the different data points, and then I multiply by basically how many rows I should have had for that value. And that way we can, again, just save a little bit of writing and time in the calculation.